Hey, what's up, guys? Chung here again. This time I want to talk about another interesting LeetCode problem here. Number 593, valid square. So it's a medium problem and it's a very interesting math problem. So not like my usual video, which always are about dynamic programming or the recursion, the backtracking, or the binary search. So this time, let's take a look at another aspect of the algorithm, which is the math. Okay, so the problem is pretty straightforward. You're given like four coordinates, and it asks you to check if these four coordinates can form a square. Right? Notice here it's a square, not a rectangle. Okay, so which means, for example, this one here. This is not a valid answer here, right? So it has to be a square. And the square, it doesn't have to be and the edge doesn't have to be vertical and horizontal, right? So for example, let's say we have a coordinates x and y here, right? So we all know this is a square, right? And but this is also a square, right? So basically that's the tricky part of this problem. And so actually the core concept here is how can we make sure, right? This this like this thing, this graph, this geometry graph is a square, right? So it's a square. Square. What does square mean? Square means first, each of the edge are the same length, are the same, right? Second, the these two are also the same, right? The diagonal and anti-diagonal, those two diagonal lengths are also needs to be the same, right? That with those two conditions, we can be sure this is a square. So, and now the question comes down, how can we calculate the length, right? The edge, the length of each edge. Basically, what's the edge here means? It means that the distance between two coordinates, right? So how can we calculate the distance between the two coordinates, right? I'm pretty sure you guys all have learned uh, Pythagoras theorem when you were at school, right? If we have two coordinates here, right? Let's say we have two coordinates. So the distance of this one will become to, let's say we have a x, y, and z. X, y, and z here, right? So based on the Pythagoras theorem, z squared equals to x squared plus y squared. Okay. And what is x? What's the x? X means the the core the two coordinates, right? The x difference of those two coordinates, and this length y equals to the difference of the y coordinates. Okay. So with these two things, we can calculate each edge, right? Let's say there's a 0, 1, 2, 3, right? So basically, we need to calculate six distances and compare them, right? And another thing is that the input points have no order, right? Basically, we have to somehow find a way of sorting this input coordinates so that we can arrange those points in a certain way so that we can be sure know which two are at each side of the diagonal and anti-diagonal, right? So one way of doing this is either we can sort by the first element. We can sort by x and then by y, right? If we sort by x then by y, then what we have here is that we will have p1. We'll always have like basically we'll have the like p p0, right? And then p1, and then p2 and p3. That's the sorting because we sort. Let's say for this is x and y. If we sort by x and then by y, we'll have p0 here, p1, p2, and p3. Same thing. For example, if we have another like rotated square here, right? So sorted by uh by x. So this is gonna be p0. Uh, how about p1, p2, p2? Let's say p1 and p2 they have let's say these two coordinates have the same y, right? So this is gonna be p2 and p3. Sorry, p1 and p2 and p3. As you guys can see already, right? So if we sort by x and then by y, so the p0 and p3 are always two two coordinates for the for one diagonal, and p1 and p2 are the other points, endpoints for the other anti-diagonal. So we can just sort by the by x and y. Then we can use this one to compare the distance between those two. And as you guys can see, actually we don't. Of course, we need to compare the two diagonals, right? Two diagonals length. That's for sure. And for the other edges, we don't have to compare everything. We can after we compare the two diagonal lengths, we can just compare one set, right? We can pick any of them. We just need to compare two side plus the diagonals. Then we can be sure it's a valid square, right? Uh, okay, so that's one way, and the other way is like, hmm, the other way that okay, that's first way to sort the coordinates first. And there's another solution it's also got very interesting is the basically we just blindly get six distances, right? Uh, P1 to P2, P2 to P3. Basically, we blindly get six distances, like P1 to P2, P2 to P3, and then P3 to P4, P4 to P1, right? And then we also blindly get the other two distances, P1 to P3 and the P2 to P4, right? Basically, that's all the six edges we have with those four coordinates, right? So once we have those six lines here, we can simply do a sort, right? We do a sort for those six lines, and then we check if the first four are the same and if the last two are the same, right? Because if the if it's a square, right? So the first four will be the same because that's the four edges, the four side edges, and the other two, which will be a little bit longer, are the diagonals and anti-diagonals, right? So that's another way of solving this problem. And okay, so okay, I'll try to code this problem up here. Okay, so first I'm gonna define like helper functions to get distance, right? Get distance, okay, and the p1, p2, okay. So we simply return the P1 dot 0, that's the axis, right? The x coordinates minus P2 dot 0, and we just time it by 2, right? We do a square of that. Same thing for the P2, sorry, P1 dot 1, right? Minus P2 dot 1, right? And we do another square. So actually we need to do a do a log by 2 to get the real length, but since we're using basically the squared version of the distance to represent the distance, it doesn't really matter as long as it didn't, as you guys can see, the the input integer is kind of within 10,000, so there won't be any overflow of the integers. So that's why we can use a square version of the distance to represent each distance. Okay, so that's that. Okay, so the first version is we're gonna do a sort, right? Basically, I'm gonna do a p hmm, p list here, right? I'm gonna do a p list p1, p2, p3, and p4, right? I simply do a sort, right? So because we don't need to do any key or lambda functions here because we want to because we want to sort by the first by the x first and then y, right? Basically, that's happens to be the default sorting, right? The key if we don't do anything here, okay? And now we have the that sequence, right? We simply do a return get distance. So the p list 0 and okay, we'll compare the two diagonals first, right? So that's 0 and the p list 3, right? Equals to the get distance p list 1 and p list 2, right? So that's the first one. And that's the two diagonal line. And then we just pick any of the two edge and then compare their their distance. Okay. So okay, I'm gonna copy this thing here. So in this case, I'm just picking the 1 to 0, 0 to 1, and 0 to 2. Okay. So and there is like a corner case, edge case. If all of them is 0, which means there's no area for this square, right? What do? We simply check. We check any side, right? If any of the edge is not 0, right? We still end here, and then it should just work. Okay. Yeah. Yeah. So that's for the basically sort the list, sort the the coordinates, the points in certain order, so we can be sure which two represents the diagonal line and which of the other two represents the edge, the edge line, and we simply compare those two, do a two comparison. Okay, I think that's it. So for the others, so we do the other I'm not going to implement here. But basically we get all the we blindly get all the distance, right? For P1, P2, for all those 6 edges combination, we put them into a list, and then we do a sort, right? And then we compare the first 4 if they are identical, and then we compare if the last 2 are also identical. Yeah, you guys can try to implement it if you're interested. Uh, okay, cool. I think that's pretty much it is for this problem. Yeah, you know, once we have done so many hard DP problem. It's not a bad thing to try something different, right? For example, this kind of small or interesting math problem, right? Just try to refresh your memory and to pull you away from that DP abyss for a while, right? So that you can try something different and then jump back to that to dynamic programming later. Okay, cool guys. I think that's it for this problem. Thank you so much for watching the videos and stay tuned. See you guys soon. Bye bye.